All right, we've got a lot of slides to get through in 45 minutes, so I'm going to go ahead and get rolling. My name is Brian Kinlaw. I am a Principal Solution Architect for CSC. And how many of you have, are on the business side versus the technical side? How many of you feel like your customers are clients instead of high-level technical people that have got, a decade of experience with Hadoop? All right, so most of you have had some experience with Hadoop. Most of you have touched it before, you felt it, you've actually installed it, you understand what it is. How many of you have actually installed it before? All right, that's a nice blend. All right, so the idea behind today's conversation is just about the fact that installing and configuring Hadoop is like step one to being part of the big data environment that everybody's talking about, these days. However, there's a lot more to it. It's not a silver bullet. It's not everything. It doesn't solve all your problems. There's a lot more integration that has to occur beyond just installing it and configuring it and testing it and playing around with it. My background is that I've been working at CSC, and I've been in this space for the last, since about 2011. My start was with social media analytics. I was part of the IBM team that built social media analytics, and then that led to what is now Watson. And I've worked with federal a lot. In fact, some of the largest opportunities that we've had at IBM, I've been on the team that led those and developed those and built those out. I am now at CSC because we have something called BD Pass, which is very similar to the architecture that we used to use when I was at IBM. And the biggest thing that I think that I like about it is that it allows you to rapidly evolve a solution. You can walk in a door, you can talk to a customer or talk to a person, identify a use case, and instead of you spending all your time building the foundation for solving the problem, you can spend most of your time architecting the actual logic associated with building solving the problem. And that is really what today is all about. It's really about talking about how to get to that point where you're solving the problem and not just flipping bits and working with the infrastructure required in order to solve the problem. So when we first started out, there was what's known as Big Data 1.0. Big Data 1.0 was when we came out with really large solutions, really big RDBMSs, enterprise level to solve all of our L's, all the problems that we experienced in the world. Soon we started running out of batch jobs started running too long, and we began to realize that the larger the data got, the more massive the data. I'm sorry, I'm flipping this screen and this one's not moving. All right, so what I was saying is that when we first started out, we started with simple enterprise data warehouse, enterprise level data, and as it got bigger, as sensor data developed, and as the need to evaluate that data grew, we decided that the simple solution to the problems that we were having was to create an appliance. And so we created appliances. You've probably seen them before, and Netezza is an excellent example of one. And although they were great for our most expensive, heavy-duty, the work that took forever, they were also very expensive. So when technologies like Hadoop started emerging, people started building solutions around them, and that's kind of where we are today. And when we look at where we are today, one of the things that we want to be able to do is we want to be able to identify and shape problems around the current environment. So what that means is when I walk into an environment, I'm not walking into an environment to replace an EDW. I'm walking into an environment in order to complement an EDW. I might want to look at it from the customer's perspective. The very first thing I want to do is identify all the use cases and all the patterns that exist. And if I'm identifying those and I'm focused on those, then what comes next is that I throw a piece of paper on the table and I show them what they just said, and then they tell me, yeah, that's it. That's exactly the problem. Now, the thing about big data is that big data is, the technology is not what the issue is. I mean, I could put together a series of patterns all day long. The solution to the problem is actually understanding from the perspective of the user where the bottleneck is and relieving that bottleneck. So it's not that you're going to rewrite their EDW. It's not that you're going to, it's really that you're going to solve the one problem that they have, which is getting this one particular report out more quickly than they thought they could. I've got a couple of examples that we'll go into. And here are a couple of examples of clients that we've worked with and things that we've done. And from a government perspective, I think the thing that you guys are all looking for is a simple way to implement your environment, and a simple way to evolve the environment. Those are the hardest things to do in a big data world. To be quite honest, once we get the production environment going, it's kind of hard to get it stopped. So one of the things that cloud does for us is it gives us a way to separate what we do on a day-to-day basis and what's required to what we think would tweak it and what we think would streamline it and what we think would make it go faster. So here are some examples of the traditional risks that we face in a typical environment. I mean, the hardest part about all of this is that it's expensive. It doesn't scale. We have disparate, and the biggest problem that I run into in almost every environment is the data silos. And when you first build them, you don't think of them as silos, right? When I first build when I first install a platform designed to solve a very specific problem, it's not a problem. I mean, it looks like the wonder solution to everything that I've ever wanted to do. But then when I solve for another problem and I solve for another problem, soon I have data silos. The hard part about all of them is, as with big data, you've got to figure out a way to link them. You've got to figure out a way to make them work together. And that brings up new risks, right? The new risk is, if I link them together, am I linking them together correctly? Did I do it right? Did I think of all the variables? And you know what? I just learned Storm, so I implemented it. Is it actually the best solution? Is there a better solution for it? How does Kafka work? These are all questions that come to mind when you're installing and configuring something that you just learned. And because you're kind of doing something new to your organization, nobody's ever sure that you're doing the right thing. So it becomes very difficult when you don't have somebody to bounce the ideas off of and make certain that they are correct. So here are the challenges that you face, right? The first one is implementation. How do I install it? The second one is operation. Is it robust? Is it scalable? Does it allow me to do backups? How secure is it? From a data science perspective, it's all zeros and ones, right? We kind of know what we're doing with regard to the current data, but how does that change when we go to something that's open source? From a talent perspective, all of this is about talent, right? Do I have the skill set necessary to do this? And am I implementing something that is a little too advanced? And how stable is it? From an infrastructure perspective, it becomes expensive if I don't know what I'm doing. Because why? Because again, this is, my company just trusted me, or my agency just trusted me. They just spent a massive amount of money on configuring something that is probably bare metal. If I want to change it, I better be right, because I get one of them. I get one shot. I've got one cluster, one hierarchy from an organizational perspective, and I've already persuaded them that I was doing the right thing. So the difficult part comes in that this is what I need. I need a new strategy, right? I need a way to do all of these things so that I don't conflict with my ongoing operations on a day-to-day basis. And that's where this approach comes in, right? I mean, initially when we first start out, we're solving for simple problems. We want to know what happened. We want to know why it happened. But truthfully, the Holy Grail, the thing that we're all after right now, is we want to identify the patterns that are occurring over and over again in order so that we can make them happen, or in order so that we can stop them. If we're searching for terrorist activity, we want to stop them. If we're identifying information bottlenecks, or we're identifying, for example, if I were a healthcare organization and I were trying to identify sepsis and the things that lead up to it, well, that ability to analyze those patterns in order so that I can predict when something's going on that I don't ordinarily occur, that is like the Holy Grail, the prescriptive analytics. Figuring out how to make that happen over and over again so that I can help save lives is kind of crucial, kind of critical. And then from a fraud perspective, maybe I have somebody that's in my network that shouldn't be in my network and that is fully leveraging information about others in a harmful way. Maybe they're stealing identities. All of these things are still things that are possible within the environment if somebody knows how to manipulate the environment. If I can identify the clues, though, and I can pour through the data, it becomes very easy to solve these problems. So with that in mind, there's a stepwise process that we go through in order to help identify those things that people are worried about, that are ongoing. And from your perspective, it becomes very important for you to follow a very simple pattern. And that is, you want to shape the environment. You want to identify everything that's going on currently that might impact the individual problem that you're trying to solve. And you want to do it not from a technical perspective. You want to do it from a business user perspective, and then you want to look at it from the outside in. And that's a phrase that people like to use nowadays. What it means is you look at things from all angles. You take a 360-degree look at all data. The ability to transform what you're currently doing, your legacy systems, to a new system, all of that is based on speed of implementation and whether or not you can do it quickly enough to keep your current customers happy. So with that in mind, what we do is we use this a rapid development cycle. This rapid development cycle that we use allows us to focus on the use cases and developing them. But we do them in a way that makes sense. And what I mean by that is, let's say I have a production environment, and then I mimic I make an exact copy of the production environment in a cloud setting. Let's say there's a transformation that takes a lot longer than I think it should. Maybe I want to break it into a couple of different parts. Maybe I want to analyze those parts, and maybe one of the transformations that I'm doing that I broke into, maybe I want to scale that out. I want to add a cluster just for that transformation. These are the types of things that we can do. Alternatively, maybe there's another way of processing the data. Maybe instead of using a batch transformation like I've been using, maybe it's better that I change everything that I'm doing into an event. Maybe I start looking at those events and logging them to a queue. Maybe I start processing all my downstream data off of that queue. Maybe these are the different types of things that we do, but the point is that you can gain insight by trying all these different logical models and figuring out which one works best for you. It's easier to do that when you're in a cloud. And so when you're trying to build an impactful outcome, this is a real easy stepwise process to doing it. I mean, the only problem that I don't like, I realize that we're trying to make this simple. We're trying to give a 5-step process for it. But truthfully, I told you about the phrase outside in. If you look at tools and technologies from an outside perspective, and just so we're all on the same page, when I handed this deck over, it was perfect. I don't know how these fonts got all messed up, but the point is when you start from the outside, like let's say I started with tools and technologies, maybe I know those really well. Maybe I feel fairly comfortable with the tool set that I've been using from a big data perspective, whether it be Pentaho or it be Hive, I'm comfortable with it. And I know its limitations. So so that's the one thing I have in the back of my head. The other thing I have is the business side. And then I kind of work my way in because I know the limitations of the tools and I know this problem that I'm trying to solve. It is not necessary to follow this in an exact stepwise fashion. It is important to understand how all the variables are going to fit together once you start mapping them. Now, we have a couple of case studies here, but the problem with case studies is that the case studies that we have are not actually related to government. What I'll do is I want to blaze through these and get to the end and then hopefully answer some questions for you guys related to your unique situations. One of the things I used to hate when I was in public sector is when people gave me examples of retail stores when I was never going to use those examples. So this is an example at a high level of what the architecture is supposed to do. We need to determine, what type of data flow it is. Is it a batch data flow? Is it an ad hoc data flow? Is it real time? When we pull it in, how do we deal with it? From a query perspective and from a distributed processing perspective, is Hadoop the answer, or do we need to be using something else? And then from a deployment perspective, it's important to know how we're going to deploy. I mean, and there are lots of options on deployment. Of course, the one we're here to recommend today is the cloud-based format. And that brings you a lot of things. One of the things that the overall approach that we're trying to recommend to you today brings you is it allows you to make decisions about what you're going to do in isolation, meaning that I'm not limited to whether I'm going to use Cloudera. I'm not limited to whether I'm going to use Hortonworks. I'm not limited to the distribution that I'm going to use in terms of whether it be a Hadoop or Storm. If I want to use a particular type of reporting platform, I can use any one that I want. The way this all works is that it's all automated. So as I'm deciding what it is I want to use, we have an automated Puppet environment that's orchestrated, which means that if I decide today that I want a cluster with five nodes, and that I need Kafka, I need Storm, I want Pentaho for my reporting structure, I can spin all that up in less than 30 minutes. And it's not difficult. It's not difficult because we've already integrated it and we've already written a Puppet routine. We've got our IP, the things that we do, the thing that makes this thing that we're talking about really unique is the fact that we can spin it all up and that it'll all work. The only thing that you've got to add is your use case. This is an example of our standard reference architecture. The way it works is that you can see the events that are coming in you can see the events as they come in. From an events perspective, what we're talking about is streams of data. Things that are ongoing, like log files, for example, or the other alternative is files. Just batch files like you're used to. Maybe they land in it, maybe they're FTP'd over. In any event, we tend to treat those things like batches. Now, the idea behind the squares with the dotted outlines underneath them is that you can scale those up or down. You can have one instance of them, or you can have multiple instances of them. You can determine how you want those to be configured. And from our perspective, all it is a click box. Command and control is kind of an important thing too. Being able to manipulate and run and spin these up very quickly is great. But how do you figure out when they become ineffective? How do you figure out when too much data has arrived in whatever you built and it's no longer optimal? Well, one of those things you have to be able to do is you have to be able to measure against it. You have to be able to track what's going on. So we provide a couple of things to help us do that. Jenkins is an example of a tool that we use in order to run tests against our instance, in order so that we can validate that instance. Splunk is an example of something that we use to pull in all of the log files in order so that we can analyze them for discrepancies, for things that are unique or unusual or outliers, or things that happen all the time and the order in which they happen in. Free IPA, that's from a security perspective. It's what allows us to determine who should be logged in and what level of privileges they should have. And again, it's one of those things that all of these are standards that ship with every instance that we put together. This is designed in order to show you guys the idea behind how having an environment like this kind of helps you. So if I'm on my workstation and I decide that I want to test out my production environment and some changes that I want to make to it, I have an exact replica of my production environment in a test setting. So this test setting I can use for two things, right? I can use it for DevOps, which is the testing that I just described, but I can also use it for disaster recovery. Because if anything ever affects my production environment, I can switch over to the DevOps environment, and I can theoretically run my business on that until I get my production environment back up. Now, once I have everything figured out on my dev environment, how I want to scale and what the best path would be for my data flow, I can push it to the production environment, and now I have zero downtime. Everything works as planned, and it's a mirror image of the production environment. So the idea behind having a cloud kind of makes all of the things that you would ordinarily be worried about go away. Now the other thing that happens when you have this cloud instance and you have a managed instance, I mean, because we can provide it either way, right? We can either give you access to your own cloud instance and you can manage it all yourself, or we have a team of people that would help you. And so we would form that steering committee that you don't have right now. We have like 100 people in Austin alone, but globally we have about 1,200 people that all have this data background that I just described to you. So one of the things that we like to do for customers, we like to put together strategy sessions for them. So what they'll do is they'll call us, and we have some pretty large customers that use this service. And what they'll do is they'll call us and they'll give us the lay of the land on what they're trying to do and the ways they've come up with to try to do it. And what we'll do is we'll just think tank it with them. We'll bounce some ideas off of them. We'll help them build a representative example, a POC that proves or disproves whatever it is they want to do. And then we'll help them implement it in the real world setting that they want to implement it in, regardless of whether or not it's on our cloud or it's in their environment. Now, what this is designed to do is just show you that it's way easier if you've got to make a change to make that change in the DevOps environment than it is in the prod environment for the very first time. This is an example of that outside-in process that I told you about. So if this were a real-world scenario, what we would do first, right, is see the blue area? We'd build it out. And then we'd connect to it, right? And in connecting to it, we'd build perhaps maybe a custom connection, an HTTP connection. Perhaps maybe we'd pull in some data from some social data. All of that would be our production environment, our production big data environment that augments our EDW. Now, beyond that, though, we'd want to create the green area right here. The green area would be the DevOps environment. And what's wonderful about this is that all of this is a click away from our perspective. We've already integrated. We've already got Puppet routines that do it. The idea behind this is that it shows you theoretically what I could spin up if I wanted to as it relates to the capabilities of our platform. And again, none of this, all of it is point and click, drag and drop. Now this kind of shows you where the Amazon layer plugs in to some of the stuff that we've built, and how it lays on to how we lay on top of it and how we orchestrate it. So all of those connections that you saw, all of those, they're all, technically in the cloud. And we are all here, at the AWS conference because we hopefully intend to use the cloud. And I just wanted to show you what the vehicles are that we're actually using when we say that we're setting up this logical representation of your production environment. So from a public cloud perspective, these are some of the benefits of public cloud. I think the one that I obviously believe is true is that efficiency is kind of like the best thing. There's efficiency, and then when you have a managed service and you don't know exactly what you're doing with regard to a new integration, you've got support on an ongoing basis, 24/7. This last slide is just about security. I mean, because that's kind of crucial to all of us, right? Security is very important, and one of the things that we do currently right now is we maintain security for one of the largest databases that the United States government holds. And we're not allowed to talk a lot about it. I can't say specifically which agency, but from a security perspective, it allows you to have cell level as well as row level security, and there's a lot of other capabilities that go into it. This kind of I believe this is the last slide. Do you guys have any questions or anything you'd like to talk about? Anything that I didn't cover that you have questions about? I see one hand going up.
So running EMR cluster against an S3 storage compared to running a Hadoop cluster on physical hardware against your own HDFS, you have that problem of data locality. Have you done any studies to compare the two, and what kind of impact you might see running Hadoop in a virtualized environment against S3?
The answer is yes, and I'm not saying that it's ever going to be faster. It's not. It's not going to be faster. The idea is that it'll help you optimize it. So, like technically, if it's like running through water, right? It's never going to be as fast as running on ground, but hopefully all things are relative. And if something's slow in your bare metal environment, it'll be slow in the virtualized environment, but you'll be able to hopefully figure out a way to break it into components so that you can take some of the load off of it and it'll run faster.
What are you using for cell level security?
Sorry?
What are you using for cell level security?
Again, the most specific I can give you is that what we call it internally, its code name is EasyBake, and we can get into some specifics if you ever invite us out to your site, but in a public setting like this, I can't go into great detail. I cannot see anybody. Any other questions? All right, well, thank you. That concludes our presentation for today.